recording should be on.
Cool. So welcome everybody to this other episode of the Telemetry Working Group. We have a web page up on the Open Infra Labs page. That's great. It's openinfralabs.org/telemetry, if I'm not mistaken. openinfralabs.org/telemetry. Correct. And it's also connected to our GitHub repo, which is still the place to file issues and ideas on what we could do. And I think today we will talk about what Raja's students are doing together with Tom, like a small update, how they're deploying their workloads on the Operate First server. And then we also discussed that some of the research might be not really blocked, but might be slowed down by the availability of data. And that was a good segue into the fact that we're already creating data and that we're already collecting data. So we have Michael Clifford from Red Hat's AI Ops team talking a little bit about the logs, events, and metrics that we're already collecting in that Operate First cluster, just to give those guys who are not familiar with the kind of data some intuition about what you can expect. So that's basically stuff from the long-running environment that we have, which is creating data on the fly, and we're trying to not delete it. And we also have Anand from the same team talking about long-term storage of this data. So I think he will give a quick update on how you can move your own time series into that setup, how you can move your own logs into that setup, and how you can get access to it. And again, I want to extend to everybody. It's an open community. If you have workloads to run there, we have onboarding processes. That's all great and good. So, Raja, do you want to take it away?
Sure, why not? Who's the host? You need to enable screen sharing.
All set, Raja.
Hopefully folks can see my screen. So this is a bit more broad than what.
Your audio is very faint, at least for me. Maybe move a little bit closer to the mic.
I'm having a hard time hearing you also.
All right, is this better?
Yes.
Yes.
Cool. So interestingly, it's possible to use my webcam and the microphone from my laptop instead of the microphone from my webcam and the video from my webcam. So consistency issues. I'm going to talk a bit about some of the research that we're doing at Tufts at my lab very quickly, and then try and draw like a correspondence of how I'd hope, or it'd be great if we could either get data from Open Telemetry to support it, or try to run these things. Try and get data from Operate First to support it, or try and run these things, within Operate First itself. So with that, 3 big projects, right? The first one is simply trying to understand what microservices are, what are the design principles behind them, how can you characterize them, right? So there's a lot of research in academia right now that focuses on, well, how could you improve microservice architectures? We did X, Y, and Z, and we improved the performance of this microservice application by Y. So all sounds great, except that right now we're all using these really toy benchmarks of microservices And we suspect that the design space of what people think microservices are is really, really, really big, right? So how can we say anything about improving performance or improving microservices in general unless we design how they can vary? What are the different design axes? What are the principles that go behind creating them? And so we're just trying to wrap our heads around what this term means more generally. And so we've been doing a couple of things. One is in the operate first environment, we've been deploying a set of these sample example microservices that are out there. Some of them are called book info, get star bench, train ticket, and so on. There are a bunch of these things out there. We're deploying them so we get data from them, get traces on them, just to see what the traces look like, just to look at what the microservice applications look like. In concert, my research group, I have 2 brand new PhD students who are running user studies with basically experts from industry to understand what they think microservices are. So we have a bunch of very targeted questions, trying to gather some experiences of how microservices are architected, where do databases go, right? How much sharing exists within a given service within a microservice? How much is that service shared between different applications? How much, and so on. So there are a bunch of questions like this that we're trying to use to get a sense of whether we can characterize microservices. We just started that, ran the first interview on Monday or Wednesday last week, and we're going with that. Hopefully there'll be some results soon that we can talk about. Of course, we're not the only academic group running user studies to understand what microservices are. There are a bunch of others too. So hopefully we can also figure out what those folks said. The second project is trying to improve instrumentation itself. So we're basically trying to understand how we can create an instrumentation framework that by itself is exploring what instrumentation is needed to provide visibility into new performance problems. And this, of course, tries to address the concern that, whenever we're debugging, it's always an iterative process, right? We always try and debug a performance problem, find that we don't quite have the instrumentation we need to figure out what's going on, and then we go in and we add more instrumentation, right? We're asking, can we automate that process in some smart way, at least for certain classes of problems? And the third thing is basically trying to create better abstractions for diagnosis. So I have a couple of quick slides on each one, and I can conclude each section with how this might fit into the operate first world. So better instrumentation frameworks is, sorry, I didn't hear your comment.
Oh, no, that was a good.
Okay, cool. So better instrumentation frameworks, right? So our goal here is, can we enable the instrumentation needed to kind of zoom in on or localize the source of new performance problems? And all this research is just based on this insight that at some basic level, requests that kind of do the same thing, right, in a distributed system, for example, reads that hit in the cache or reads that missed in the cache and go to the same storage disk, should have similar performance, modulo a couple of things, right? So if they don't, then there's something we don't know about their behavior in the system. And this unknown behavior may be interesting heterogeneity that would be interesting to know about. It might be problems such as resource contention, load imbalances, or just really slow code paths that are executed that we didn't know about, right? So what we can do in this case is we can zoom in on where the performance variance is coming from within those workflows and use that to guide what instrumentation to enable to explain that variance. This all sounds kind of, sounds great, but how do we obtain these workflows? And the answer is that we have that. We have this thing called distributed tracing these days, which essentially gives us request workflows. What we can do is we can start with like some tracing that shows us request workflows, figure out where the variance comes from within this workflow, enable more instrumentation there, and gradually tease out the cause of certain problems. So here's an example of why this might work. Here we have basically a request to write some data in a storage system, right? And we should write and it ends super quickly, right? And we see that the response time distribution is, very tight, right? There's really low variance, right? But maybe it turns out that our expectation that writes should perform similarly actually isn't true, and there's lots of variation, right? So now the question is, can we figure out where the variation is coming from within this workflow and enable more instrumentation to tease it out? What might be sources of that variation? Well, it might be that something's just hitting cache and missed. So if we basically enabled instrumentation around the caches, perhaps that would better tease out the different behaviors, right? It might be load imbalances. It might be that different storage nodes have different performance profiles. So we teased out the name of the storage nodes and added it to our traces, we'd be able to differentiate performance as per which storage node was accessed. It could be like request sizes too, right? Which is a bit more complicated, but essentially you could explore that as well to kind of tease out the sources of this variance. So Pythia basically operates in this this continuous cycle where it's starting with kind of skeletons of request workflows using like a minimum of tracing instrumentation is enabled, right? It kind of starts up these expectations of which requests should kind of perform similarly, maybe all reads, maybe all writes. It figures out sources of variance in these traces of these groups of requests that have these basic expectations of performing similarly. It localizes the sources of variance, enables instrumentation, and uses it to further refine the groupings it's creating over time. Right? So there's just one half of it. The other half is that even if you figure out the variance sources, you might have some requests that are always super slow, that are just consistently slow. They have low variance, but they fall in the tail of some distribution. So there's another half of this instrumentation framework that deals with that. And yet another half that deals with making sure we don't enable too much instrumentation and deal with all sorts of performance issues because we're overwhelming the system with too much tracing. So right now, our test beds for this are in OpenStack and HDFS. So we're controlling these applications tracing using this instrumentation framework. They're currently running in Cloud Lab. It'd be great to, at some point, be able to move these test beds to operate first. And then at some point, when we have a corpus of applications that are running and operate first, right? It'd be great to try and, corpus of applications that have tracing that are running and operate first, right? It'd be great to try and apply this sort of automated control to these applications as well to see where this fails, right? Or where it works. So some examples might be microservice deployments, like the one we're deploying, applications running within like Istio, which already come with tracing. Does that work? Are there things that Istio is doing that are counterintuitive and that don't work the assumptions we're making? These are all things that would be great to explore. All right, one more project. I'm going to quickly talk about better abstractions, right? So so we have lots of great abstractions to help us build distributed applications. We have like APIs, we have libraries, all these things let us build more complex systems out of simpler ones. Yet when we start debugging problems, all we have are these giant, flat, raw logs or traces lying around, right? So there's an immense mismatch between kind of like the effort we're putting into giving folks sophisticated tools to build systems versus what we're giving them to debug problems. And so what we want to ask here is, can we take these giant flat traces or logs and automatically identify building blocks, higher level patterns in them, which we can then use for problem diagnosis. And we're calling these higher level building blocks motifs. So some use cases here might be, well, can we identify a bunch of emergent patterns across a bunch of traces that are like weirdly super slow, so that optimizing their performance would speed up the discrete application as a whole? Can we reformat our trace visualizations that we have so that we can collapse out common patterns that occur across a bunch of traces, once they've been optimized, so we can create simpler visualizations or allow visualizations that can be hierarchically explored as per the common patterns that they contain or don't contain, right? Can we compare these patterns we see, right, when we see performance regressions, so, between the regress period and the non-regress period? So how can this tie into operate first? Well, like this research kind of relies on applications that are instrumented with distributed tracing. These things are actually kind of rare in the world. I know that we have Istio and so on that provide service meshes that will let us get traces for free somewhat, but still it's hard to find like a complicated application that gives us lots of trace data. So one of my hopes is that at some point we're able to build up a corpus of applications that we can get lots of traces from and go from there. And that is my little research summary. So I can take any questions or thoughts, or if not, we can move on to the next topic. Cool. Marcel, should we move on to the next topic?
Yeah, if nobody has any questions. So is motive, I just recently learned about the term motive. Is that a common term in distributed tracing or when looking at time series data, or is that just a plain English term that I haven't seen before in that context?
A motif is just a recurring theme or recurring pattern. Like people talk about like music all the time. Like a motif is like a distinguishable piece of sound that occurs frequently in like a musical piece. People use motifs in like time series data to describe repeating aspects of a time series that show up over and over again. We're trying to apply the concept to trace data to see if we can identify these kind of building blocks or higher level patterns and traces and present them directly to developers. So the terms existed for a while, and the term gets applied to different domains in different ways.
I know it from German crime literature. So we're always looking for the motif of the killer, why he killed the person. So that's the motif, why he did it. Right. Which makes sense also for time series. Sort of.
Makes sense.
Okay. Then should we move over to Michael, the data that is being collected from the OpenShift clusters?
Yes, I would be happy to go next. How do I share my screen here?
At the bottom of the screen, there should be a green.
Share screen in big green letters. Thank you. Perfect. All right. Can everyone see a GitHub repository?
Yes.
Excellent. Cool. So what I'm going to talk about here today is some of the data that we have already available for people to use that's being exposed by the Operate First cluster. I'm going to use like notebooks and stuff, and particularly taking it from like a data science point of view because I'm a data scientist. But I think one of the things to get across here, and maybe everyone in this audience already knows this, is that the AI ops problem in general has kind of been hindered by the fact that all of the data is proprietary and locked up into different companies, and there's not a really good golden standard open source of this type of data. So that is what we are able to produce with the operate first cluster, is have actual production logs, events, and metrics of data that we can share and provide with anyone. So everything that you'll see here, as long as you are like signed in to the operate first cluster, you should have access to it. So, and feel free to stop me at any point if you have questions or anything at all. So again,
Hey,
if anyone's interested.
I do have a question. This is Gretchen from Intel. So are there things that you need from Intel? And if so, if you guys could make a list of those things, I mean, some of which we probably, because it's proprietary, we may not share with you, but it would be good to know what are those other telemetry components that you're looking for that you're not getting from the hardware and software and peripherals that are Intel's. It would be good to get that information back to folks, and maybe there are ways to unlock some of that.
Yes, so I can speak to that. So far, we're just collecting the cluster monitoring operator metrics and the components that, or the operators that are part of OpenShift. We haven't even stuck any GPUs or other components in that would gather specific metrics from hardware components. But if you have any what's the term? Super special and curious and like specific or not so specific hardware that might be embedded in such a cluster, then that would be awesome to also collect metrics from that or information. That makes sense.
Yeah, I can get that. I mean, so almost all of the server processors are some form of Xeon. So there's definitely telemetry that's collected there, and I'd have to work with Michael Datesman and others. We'll go double check, but I think some of the NIC cards and things like that are also Intel. So there's definitely things that can be pulled out, that you should be able to look at in terms of traffic and some of those kinds of things.
So if you have engineers that know how to collect these metrics, please redirect them to the Operate First Ops team or to me directly, and I'll work with them how to get them in that collection process that Anand will talk about later.
Yeah, and for the NICs, we actually have a project going on already in the networking team, Gretchen. So if you haven't been connected with them, I can connect you as well. And of course, Larry, he's doing a lot of the work with the memory data collection.
Awesome. Thanks, Heidi. I appreciate it.
Okay, so I should connect you up with the networking folks. You haven't met them yet.
That would be great. Yep.
Okay, cool.
Cool. Great. So yeah, and just it sounds good. So anyone who's interested in any metrics coming out of the OpenShift Operate First cluster can come to this repository. We currently have, like I said, metrics, logs, and events available. So we actually have, for each of these, we have a small sample data set that I'll go through each of these in a minute, so that it's part of the repository. So without needing to access the cluster, you can just go ahead and pull these down and start to see what the the structure of the data looks like for each of these. Again, all this data is being exposed by the cluster in one way or another. So we have the source of all of them also linked here. And then we have notebooks that I'll go through in a minute that actually access the data, unroll it and explain what's there and what you can do with it. So instead of going through the notebooks here, I'll just give you guys a quick run through of actually using the the Operate First Jupyter Lab environment to go through some of this information. So we can go here. So this is my instance of the Jupyter Hub cluster, and we have our metrics data. So if we're interested in gathering metrics, if if you've cloned this repo, these notebooks exist as part of it. Sorry, I should have made that clear. And you can just run these notebooks directly, and it will connect to the Thanos endpoints, which looks something like this, where you could collect metrics. If you wanted to look at it in this format, will this show us anything? So here's some graph of the metrics, but again, it's like locked up in this Thanos dashboard, so it's a little bit more difficult to do analysis on that data directly. So we can use the Prometheus API client, which is tooling that Anand and other people in the AI COE team have been working on. And we can actually go ahead and collect this data directly and read it into Pandas data frame, which is like a very familiar format for data scientists to use to analyze. So we can do this and see all of the metrics that are available to us. We can pick out the ones that we want, and we can go ahead and read them into our notebook and very easily visualize them. And so clearly we have this visualization for the cluster memory usage here, which is fine. But the more important thing I think that we're getting is not graph necessarily, but we're actually getting the data frame that provides all this data for us. So what we get is a timestamp, and we get these set of labels that kind of define what exactly is the entity that we're getting information about and what that specific value was at that time. So that's great. So that's just normal metric time series data like you would expect. But I think like the really nice thing here is it makes it easy to get access to it, and then you can go ahead and apply like alerting or any kind of analysis that you'd want to do really simply using standard Python tools, right? So instead of using like the Thanos PromQL or whatever, I can write a short script and identify all of the kind of peak events that occurred in this data set. Or I could apply some like regression and go ahead and predict the future with this data. Cool. So that is like the set of metrics. I don't know if anyone has any questions at this point. I mean, metrics are pretty straightforward. It's just this like time series values. But yeah, so if there's any questions at this point, let me know, or I can move on to the other data types.
Is there any way of, so low-level metric data is great like this. At the same time, like I wonder if like there are like some higher level events or something that we could tie all this to, right? If like there was some...
Yeah, so that's great question. That's kind of where this whole thing is going eventually. But so yeah, so the three types of data that we're looking at right now is we have the metrics, which are these low-level time series. Then we have logs that are like inside of the pods themselves, and then we have the events that is a log-like thing, but it describes like the behavior at the cluster level.
So just to add to that, we also have alerts in these metrics. So that would, I guess, be a little higher level than memory usage or CPU usage that tell about like whether some particular alert fired for a cluster. And then, like Michael said, that we have events as well. So that those would be like another level higher, I guess.
Right. I mean, I guess like the golden setup would be like, hey, look, you know, the cluster experienced as a whole experienced a performance degradation or an outage or something, or a network cable, you know, short-circuited and stopped working or something, right? Like these kind of external events, which then would be interesting to try and predict in the logs or something, maybe as it's happening or just before it happens or something. So it seems like just thinking about the utility of this data in terms of like creating data mining techniques and so on, like you need to be able to verify that you found something interesting. And so that seems like we need some kind of labeled higher level behavior at some point.
Yeah, I agree. I mean, I think having like fully external events would be something interesting. But we also have like the cluster level events, and if we can tie them to, like, if we could take some statistical thing that tells us, you know, when some event occurred, some changes occurred in all the metrics, and we can tie that to a set of logs or an event. I think that would be valuable to kind of help predict those events in the future.
Is there something like
Cool.
Is there some kind of like ticketing mechanism or something in Operate First? Right, if someone's having like some kind of problem, like do they report it via some kind of like a ticketing mechanism?
So we're using issues right now. I don't know, is there a more official ticketing system than adding issues to support at this point?
No,
There is
not yet.
Support, the support repository for issues. There's also a support channel on Slack that people can come to.
Yeah. I wonder if just like making that public in some way that's amenable to like privacy issues would help in terms of, you know, you could be like, oh,
So that's already public, isn't it?
Yeah, the Git issues are already public. You'd have to have some effort put in after the problem was solved to collect the pattern of things that you measured and say this, you know, I'm not a data scientist, but I don't think we do the follow-up effort of, okay, what was typical of this event in some way that we could label. I think that would be a cool thing for us to try and do, but I don't think we've gotten to the point yet of doing that or saying to someone, hey, this is what you should spend your time chasing down.
Yeah, I mean, I think one of the like experiences we've had is something goes wrong with Jupyter Hub, and we'll go onto the support channel and say, hey, something's wrong with Jupyter Hub. If we're able to have something that would mine the Slack for the time that occurred, and then go back and collect some slice of data of metrics, logs, and events that could generate some data set that would be useful.
Right. Or, you know, as long as you have that timestamped event saying like someone knows the problem at this time, right? That might be a data mining opportunity, might make a challenge, right? Can you find something in all this data that's being made available that could have predicted this problem or could have identified the root cause? So, you know, without even have gone through the effort of like going and labeling what was actually done to figure it out, right? Could someone go in and view this as like a data set challenge and figure out, try and predict the root cause or something related to root cause based on all this data that's being made available around that time frame?
I think
Yeah, that's interesting. I mean, I think that's like definitely the next step with where we're going with this is we need to be able to tie this information to some catastrophic or not event that we want to predict. How exactly we do that, I think, is still an open question.
I like the word catastrophic there. That was great.
Catastrophic or not, I mean, you know, something that you don't want to happen. Cool. Any other questions? Awesome. So yeah, so this is just the time series metrics data. So, and this I think is easy to visualize, pretty straightforward. The two data types that I think become a little bit harder to figure out what you have and how do you actually use it usefully are the logs and the events. So similar with the metrics that are being exposed at that Thanos endpoint, we have all the logs being stored in Elasticsearch, and then Elasticsearch can be used to like query the data directly. However, if you want to like a dashboard view of it, we have a Kibana dashboard that you can use. so you can like see kind of more easily what is there. And you could look at the log level and the message for these things. But again, this has the same problem with Thanos, is if you really want to like analyze it or do something more sophisticated, it's kind of like locked in this dashboard view. So it's good just to get a sense of what you're looking at, but you're ultimately going to want to like pull it into a notebook for analysis. And again, Elasticsearch does have a like Python API, so that we can interact with the data more directly. That's like on the immediate to-do list. That hasn't got done at this point. So right now, somebody who wants to get their own data like programmatically from this can go ahead and use this curl command, which is basically what I did, to pull a data set and then store it into the repository. So it's just like a one-off local data set, but this data is available to anyone. And again, like I said, in the near future, this notebook will also have the ability to just use that Elasticsearch API to get the data. But so the thing that I want to make clear with this data is, as somebody who's going into analyzing logs, they're assuming that they're going to get like a document basically that has like a timestamp, a warning level, and a message. And that's not really what is returned by Elasticsearch. So you need to kind of figure out what it is that you're getting. So like if you go to convert the JSON into a pandas data frame that you want to use, you end up getting this like single road thing with a huge nested object. So you can break that down. And again, you have another piece of a dictionary essentially that you have to parse. So there is the message, which you expect. There's all this additional metadata, and it might not be apparent to somebody what's important, how important each of these fields are, or even like how to deal with it. So this notebook just kind of goes through quickly, showing how to kind of like unroll this JSON into something that might be useful, and then going ahead and describing all of the columns. And this is really just to give somebody a quick view of like, okay, so the index is, there's only one unique value and it's the same for everyone. So that's not something that's useful. A lot of these aren't that useful. However, you can see something like, oh, pod name, and yeah, so there's 18 pods here. So we're not actually dealing with one stream of logs that are like cohesive with each other. There's like 18 unique logs that are 18 unique pods that we have logs for. So that's something that we need to deal with. And you can learn a lot about the pull of logs that you got from doing this process. And then we can go ahead and we can group our log messages by the 18 pods that we have. And so now we have like 18 documents essentially that describe the different inner workings of these 18 different pods, and then go ahead and just pull out a very specific one. So now at this point, after going through this notebook, we now have what we would expect to have from like a log for like doing data science, I guess, or any analysis on like log data, is we have this timestamp message format of log messages. And then we could do some much more sophisticated analysis on it. But let's say we just want to know the average length of each log message. We could do that quite easily. So yeah, so that's quickly kind of just the logs that are available to us, and how we can kind of wrangle them into a format that's a little bit easier to address. Does anybody have any questions about that at this point?
Great. So these are logs of OpenShift itself, I guess. That's the logs.
So these are the logs of the pods that are running on OpenShift.
Okay.
And so you can see the different pod names here.
I see. Okay.
Correct. And then, so then I'll go through events as well. It's like very similar to the logs. I will say the one issue about access at the moment is So the data set that we have available was generated by like a cluster admin. So if you want to get like the cluster-wide events, you need to either have like cluster-wide access essentially to some of this stuff. You are able to get the events for the projects that you are working on, obviously. But this is still an outstanding question that we need to solve around how do we make sure, or if we even like expose the cluster-wide events to everyone, or if we just have this how we manage it essentially. But again, the logs, or the events, excuse me, very similar type of thing. They're this nested JSON. So we can unroll it and unroll it until we have like an n by m flat data frame to work with, and we can go through the columns and determine, which ones are useful, which ones are not. For example, here we can see like the messages that we have. The number one message is stopping container registry server, and we have 887 unique messages, meaning there's like not a ton of repetition. At least in the slice that we're analyzing here. Yeah, so this is again the same thing with the logs. We can break it down into this set of log messages and timestamps for the specific projects that we're interested in, or looking at the cluster-wide view of events that are occurring. Cool, so those are the three types of data that we're currently able to show in this format. I think the main kind of next step that I think makes the most sense would be to do something like we talked about earlier, where it's not three separate like data flows, but you have some time period and you want to know the events, logs, and metrics for that time period and have it all as like one unit to do some analysis on. So that would be like what I would think would be the immediate next thing to do here. But yeah, that's essentially all I wanted to share with you guys today. So any questions or anything on that?
So just so that I understand, this is the log data of all the whatever's running inside different pods and so on. And it's all projects that like I may be a part of. Is it also possible to get the events corresponding to like whatever decisions like the OpenShift infrastructure is itself making, like about like scheduling stuff on different machines, or moving stuff around if it's moving stuff around? Might be like that seems like a piece that's always missing that we don't have access to.
I'm not.
That's the events. That's the third part of the data set here. That's the events generated from OpenShift. So there you can find like the network assignment, IP addresses assignment, which network space it's assigned to, which nodes it's assigned to, if the pod is being killed due to various reasons, and things like that. So all of these events are within these Kubernetes events.
Yeah, I think one piece missing is probably updates to the API server. That means if we have Argo CD or some user interacting with the cluster, the events are the notifications what the cluster is doing to achieve this. But if we deploy an application, I'm not sure if this is captured in an event. So if you would correlate that with the Argo CD application repository, and we have something merged, and then you have the logs from Argo CD, you should see an application being deployed there. But probably Tom knows more.
I think you can find most of it in the logs from the API service of OpenShift, that some resource was updated or changed or created. So that would be in that particular cluster operator logs. but it doesn't correlate with merges on pull requests and this kind of information that's not captured.
And I'm going to ask this question. This might be a question about like the goals of like the operate first cluster itself. If as a researcher, someone came up with like this fabulous new metric related to say OpenShift or some other infrastructure level piece that they wanted to capture, are we open to somehow exposing that or capturing it and then making it available? Or is this more like, oh, look, there's a bunch of existing information out there that we can capture. You know, what can you do with it? Versus, you know, how can we improve the telemetry infrastructure itself?
Definitely, if we can transcribe those findings into, for example, Prometheus rules, we can make those as a native alerts within the platform. If we can't make it into a simple Prometheus rule based on just various few metrics, and we need something more advanced on top of it to actually alert on something, then we will need to create more advanced alerting solution or bring something that is available out there, but we didn't do research into that yet.
So I think what's currently missing is a long-term storage for events. We're not storing them for long-term. We are capturing all alerts that are being emitted by Prometheus and the monitoring thing into GitHub issues. Also, if you're looking at the application level, things like Jaeger or distributed tracing, that's another research effort, but that's just on the operations, on the workload layer of the stack. There's only very little of OpenShift itself and the operators that is being instrumentalized and has these hooks for tracing. So that would be another valuable source that I'm seeing, like traces for workloads, and then correlate that with events of the platform. I'm pretty sure that most of the underlying hardware is being captured by OpenShift itself. I think that's the C node exporter. What is it called? The node. It's the node exporter, right? And the node exporter exports CoreOS logs, basically. At least in my naive worldview.
Also, I think etc daemon logs may capture some of these hardware related stuff, but I don't know, maybe.
Yeah, I know capturing the traces would be fantastic as something we capture long term. I know that like Tom and like the students in my class are currently dealing with issues related to getting traces from operate first, because it turns out like there are weird dependencies between like Istio and whatever other software that is running in the cluster. But maybe that's an opportunity to sort that all out and think about how basically like the at least the framework level traces could be captured and stored. I think that doesn't say anything about the application itself. It'd be cool to like somehow be able to integrate like the traces that like Istio or whatever else is providing with stuff that's going on inside these applications. But this would at least be a first step there. So I don't know, maybe they can talk a bit, the students could talk a bit about the challenges they've been experiencing, and Tom could too. And maybe that would be a good first step. Tom, does that make sense? Like I just got this report from the students saying that the Jaeger guy, like,
yeah,
we had a Jaeger guy and he disappeared. The way they phrased it was fantastic. And
yeah, we're struggling with basically we have other workloads on the cluster that we need to support and we have users for. So we don't want to break it. And that's basically, we don't want to break Kubeflow, which is a dependency for all our data science folks who use it for automating workflows and stuff like that. And Kubeflow is bringing their own version of Istio, which is not compatible with the upstream, and yada, yada, yada. So I'm trying to resolve those issues, and it's taking me far too long time that I would like. But yeah, that's basically the root cause there.
That's also because we're right at the beginning, right? We only have one cluster and it's a multi-tenant cluster, so we can't be as deliberate as we would be if we would have more clusters that we can experiment with. I think it's getting better in the future where we can have these sort of scenarios, but still in the meantime, I think that's way better and way more than I had even at all my time at Red Hat. But he couldn't get a hold of all the cluster logs. He couldn't get a hold of all the telemetry data of a cluster which actually has stuff running on top of it, right? So even internally, it's tough to get a hold of that data. And now I think we have like 2 weeks worth of data being stored somewhere. Sometimes it crashes, sometimes we lose some data. So it's not too bad, and we still need to find more storage for this kind of stuff. But once we have Istio and Jaeger on top, I think we're getting even more complete picture. And hopefully in a year from now, we have these data sets with all the events, all the issues, all the problems that are hidden in there. And then we can do all the fancy research on top of that, like visualization stuff, pattern mining, motifs. Cool. I think we're running a little bit out of time, Anand. Unfortunately, I don't think 6 minutes would be worthwhile going into all the good stuff that you have prepared. Do you mind rescheduling for in a month, in 4 weeks?
Yeah, that should be fine.
Cool.
I think in a month with Anand's setup on Loki and all this stuff, we may be able to demo also events collection using Loki and making that happen. So that would actually allow us to pair logs and events in Loki and bring this one step further down the road. So that would be even better demo next time.
Yay, that's good. So
like
basically
work,
what
right?
Anand wanted to show is like, how do we get all the data that Michael just showed in long-term storage, and how you could get your own data in there. Because in the end, if you write an application and you want to instrument it, you would write a Prometheus exporter, and then you configure Prometheus so that it scrapes the metrics. And same for logs. But that's a push model, I think.
Yeah, if you guys want, I can just do the demo like super quick, 2 minutes.
Yeah, or we get another bio break. I don't know.
We
Who's
can
for
do
bio
next.
breaks? Who's for demos?
We'll just do it next month.
Let's do it next month. It will be feature complete. Okay. Good. But I think that was super, super helpful, Michael. And I'm super curious on the nice infrastructure that Anand has created with the help of all the other ops people. And whoever wants to be part of operating this cluster, Lars and Tom here and Anand, I think we're welcoming every hand on the keyboard helping there. It's all super open, and it should be discoverable as any other open source project. With that, thank you. See you in about 4 weeks.
Thanks.
Bye-bye.
Bye.